Good day, students. This is Mr. Morales, and we are doing, day 51 notes on imaginary numbers. Now, this isn't like a whole new number system where we're going to learn all new names and types of way of counting. This is basically just a shorthand version of explaining an idea. Now, here on the left-hand side, it says the imaginary numbers, and it gives us some notes and examples. Our first bullet point says equations such as x squared plus 1 equals 0 have no real solution. So mathematicians define the imaginary numbers to represent their solutions. So in other words, we would need a number for x squared that we would add to 1 that would equal 0. Well, we would need to add a negative 1. Remember, there is no number times itself or squared that will give you a negative 1. So mathematicians came up with what they call imaginary numbers. Our second bullet point explains that the imaginary unit I is defined as I is equal to the square root of negative 1. This is useful when working with square roots of negative numbers. A pure imaginary number is written in the form of b times I, where b is a real number and I is an imaginary part. This will make more sense when I get into the examples, but basically, whenever you have a negative square root you need to find, you're going to use this imaginary number we call I. And it's a placeholder that kind of has different properties that helps you find negative square roots. Because up until now, we know that a negative times a negative is a positive, and a positive times a positive is also a positive. But there is no number that we know of times itself that will give you a negative answer. So the three steps we're going to use to simplify negative square roots are as follows. We're going to rewrite the square root of a negative a as negative 1 times a. Step 2 says to break down a if it's not a perfect square. And then step 3 says simplify the radical, recalling that the square root of negative 1 equals I. So remember this fact right here. Whenever we have the square root of negative 1, we can just say I. So let me give you an example of how this breaks down. We have the square root of negative 9. There is no number times itself that will give you a negative 9. So our first step says to rewrite this as the square root of negative 1 times the square root of positive 9. So negative 1 times positive 9 will give us this negative 9 in the house. Now, we know that we can find the square root of 9, which is just 3. And the square root of negative 1, we said, is I. So the way we'd write this answer is number first, so we'd say 3, letter second, I. So the square root of negative 9 is 3i. Let's try this again. Number 2. The square root of negative 196. I'm going to break this down to the square root of negative 1 times the square root of 196. Now, 196 may not be one of those perfect squares that you know offhand, but make a little note to yourself. 14 squared equals 196. So I can break down the square root of 196 as 14, and the square root of negative 1, we said, is just I. So the way I write this answer is 14i. Pretty easy, it should be so far. For number 3, we can break this down to the square root of negative 1 times the square root of 5. The square root of negative 1 is just I, but we don't have a square root of positive 5 that we know of. This is not a whole number. So I just write my answer as I times the square root of 5. I can't go any further from there without getting a crazy decimal. And we want to make our work as easy as possible. Going on to number 4, 5, and 6. For number 4, we'll break it up into the square root of negative 1 times the square root of positive 80. Now, your goal is to get as many perfect squares as you can. 80 has a ton of factors. And one of the ways I can get a perfect square root is to take the square root of 16 times the square root of 5. 16 times 5 both give me 80. So I just rewrote the 80 in a different form. I know that the square root of negative 1 is already going to be I, so I'll just bring that down. Now, I can't go any further here, so that stays there. The square root of 16, however, can be broken down to 4. So I have that answer there. And like we saw in example number 3, you can't break down square root of 5. So my final answer becomes 4i times the square root of 5. I have the 4, I I have the I, they go in front of the radical symbol with the square root of 5 inside of it. Let's try again. Number 5. I'll break this down. It's the square root of -1 times the square root of 32. I can break down, well, I know the square root of -1 is going to be I, so that's easy. That's done. The square root of 32 can be broken down to the square root of 16 times the square root of 2, because 16 times 2 equals 32. The square root of 16 I know is 4, and the square root of 2 is just some decimal number, so my answer is going to be 4i times that square root of 2 that I have left over. And we'll practice our final example in this section with the square root of 192. Once again, I'll take out the -1 and separate the 192. I know this turns into I. Square root of -1 is I. We just say I. And then I can break down 192 into a perfect square of 64 times 3. It took me a while to find these perfect squares, but you do want to always try to find the largest perfect square you can to go into each answer. And unless you go past 10, it might take some time. So I stays I. The square root of 64 turns into 8. And then I have the square root of 3, which is just some decimal number. So my answer for this one then becomes the 8 with the I times the square root of 3 attached to it. All right, so those are examples 1 through 6. That's the basic way of simplifying negative square roots. Now let's practice solving some equations. So we're going to use what we just learned in the last examples to solve some equations. So for number 7, I have x squared plus 81 equals 0. I want to know what number or numbers times itself plus 81 will get me to 0. So in order to get the x squared by itself, I'm going to have to subtract 81 from both sides of my equation. When I do that, the x squared falls down. The 81's cancel out on the left side. 0 minus 81 is a negative 81. So basically now I have the problem from above. I want to know what number times itself, or x squared, will give me a negative 81. So what I'm going to do now is I'm going to say x squared equals negative 81. I don't want x squared. I want just x. So the opposite of squaring a number is square rooting a number. So if I square root the left side, I square root the right side. X squared, square rooted, just gives me an x. So the squared and the square root cancel out. Now I need the square root of negative 81. So I'll take that work over here. The square root of negative 81, I learned in the last example, is the square root of negative 1 times the square root of 81. The square root of negative 1 I know is going to be just I, so there's part of my answer. The square root of 81, however, is a little more complicated. Yes, it's positive 9. It's also negative 9, because negative 9 times negative 9 also gives you a positive 81. Just like positive 9 times positive 9 also gives you a positive 81. So here's a new way to write our answer. We know that 9s are our answer. Positive 9 and negative 9 are both our answer. I is also part of our answer, and that's all we have. So x equals plus or minus 9i. Positive or negative 9 times I. Let's try this again. Number 8. I need to get the x squared or get the x all by itself. I'll subtract 9 from both sides to begin with. The 2x squared falls down. These 9's cancel out, and I get 1 minus 9, which is a negative 8. Next, I'm going to divide everything by 2 to get the x squared by itself. And I get x squared equals negative 4. Now, just like in the last problem, to get the x by itself, I will square root the left side and the right side. And I end up with x equals square root of negative 4. I don't know what that is, so I got to figure out what is the square root of negative 4. So negative 4 in the square root house can be broken up to the square root of negative 1 times the square root of positive 4. The square root of negative 1, we just say, is I. And the square root of positive 4 is positive 2 or negative 2. Either one of those can give me 4, and I multiply them times themselves. So my answer is plus or minus 2 times I. Moving on to the next two, number 9 and number 10. Number 9, 4x squared plus 15 equals negative 9. I'll subtract the 15 from both sides. When I do that, I get 4x squared on the left side remaining equals negative 9 minus 15 more equals negative 24. I divide everything by 4, and I get x squared equals negative 24 divided by 4, which is negative 6. I don't want x squared, I want just x. So I'll square root the left side and the right side. I get x equals whatever the negative square root of 6 is. So negative square root of 6 is equal to the square root of negative 1 times the square root of positive 6. The square root of negative 1 is just I, and we don't know what the square root of 6 is. It's just some number. So what I'm going to say is x is equal to plus or minus, because there's always a positive and a negative answer, I times the square root of 6. Number 10, same process again. In order to get x squared by itself, I'll subtract 13 from both sides. So I get x squared equals 1 minus 13, which is negative 12. So I need to figure out what x is. I square root the left side, I square root the right side. I get x equals the square root of negative 12. The square root of negative 12 is rewritten as the square root of negative 1 times the square root of positive 12. The square root of negative 1 I know is I. The square root of positive 12 is the square root of positive 4 times the square root of positive 3. The square root of positive 4 is 2, plus or minus 2, don't forget that. And the square root of 3 is just the square root of 3. So my answer now is plus or minus 2i times the square root of 3. And then we'll continue on with the next two examples on the back side for number 11 and 12. Same exact process over here. We're going to add 5 on the left, add 5 on the right. Oops, I always extra bars. My hand touched by accident. There we go. All right, so 3x squared falls down. Negative 446 plus 5 gives me negative 441. I divide everything by 3 to get x squared alone. I end up with x squared equals negative 441 divided by 3 is negative 147. I need to get x by itself, so I square root the left side and the right side, and I end up with x equals whatever the square root of negative 147 is. After a lot of practice, I found that I can get the square root of negative 1 times the square root of negative 49 times the square root of 3. Not negative 49, just 49. And 3. The square root of negative 1 is just I. The square root of 49 is plus 7 or negative 7, remember, because both of those squared gives you 49. And the square root of 3 just stays. So x is equal to plus or minus 7i times the square root of 3. And number 12. This one's a little messy because of the fraction. I'll begin by adding 1 to both sides. I get negative 2/3 times x squared equals 18. Now I have to get rid of this fraction. In order to remove fractions that are being multiplied, you multiply the left and the right side by their reciprocal. So you flip them upside down and you multiply both sides of the equation by that reciprocal. When you do that, that cancels your fractions out. And I'm left with x squared equals 18 times negative 3 halves. Excuse me, 18 times, negative 3 halves gives me negative 27. So I don't want x squared, I want just x. So I square root the left side, I square root the right side, and I get x equals the square root of negative 27. So negative 27 square root is the same thing as negative 1 times the square root of 9 times the square root of 3. The square root of negative 1 is I, as the point of today's lesson. The square root of 9 is positive and negative 3. And then the square root of 3 just stays. So x is equal to plus or minus 3i times the square root of 3. So there's the first half of your notes for today. I'm going to go ahead and cut this video and do the second half for the sake of time. If you have any questions about 1 through 12, please ask me or your teacher.